guys, this is Psycho here. Welcome to my first ever YouTube video. I'm so stoked to have you guys here. And if you're really interested in phenomena related to physics, then I suggest you to stay tuned till the end and see what happens in my next videos. So let's get on to the video then. Welcome to episode.
Welcome everybody to the lecture portion of the video. In this part, I'll talk about the key terms that are essential for you to understand and learn more about hydraulic jumps. The very first term that we're going to get familiar with is critical depth, which you can see the description on the board. So, I would describe critical depth as the height of the fluid which causes the specific energy to reach a minimum value. And I would like to remind you that since we're covering hydraulic jumps, we always assume that our fluid is water. After that reminder, we get to our most important terms, which are supercritical flow, critical flow, and subcritical flow. Now, the reason why I didn't consider telling you about these terms in the very first place is because each of those terms depend on the first term we learned today, critical depth. The relation between flow terms and critical depth would appear on the board now. So what you can understand here is when the depth of the water appears to be less than the critical depth, what you see in the open channel tube happens to be a supercritical flow. When you observe the depth of the water in an open channel at the same height as the critical depth, that means the water in the channel flows in a critical flow. The last observation you can record is when the water depth becomes much higher than the critical depth. At this point, it would only be true if we say that the water in the open channel flows in subcritical flow. Now is the time to refer to a very important number, that is the Froude number, which is a non-dimensional number. I will explain this number as a fraction of inertial forces over gravitational forces. You can also take a closer look at the board to see the fraction that creates the Froude number. This number is also very important since it has a certain relation with flow types that I talked about 7 seconds ago. If the Froude number is greater than 1, it means that water gained more velocity and started flowing in a supercritical form. If it is equal to 1, that means water is flowing in a critical form. When the Froude number is less than 1, that means gravitational forces dominate the inertial forces, and that causes water to lose its velocity, become flowing in a subcritical form. Now, since we're finished with learning the key terms related to this phenomenon, we can get to talk more about the formation of hydraulic jumps. Hydraulic jumps occur when water transitions from supercritical to subcritical flow. When we create an open channel tube like this, we can observe the hydraulic jump perfectly. At the starting point of the channel, the flow is being started with supercritical flow. Then, in the end portion of the tube, some pieces of barriers are added to easily transition the flow to a more steady state. At the very exact point where supercritical flow transitions to a subcritical flow, hydraulic jump appears. This is something engineers use in civil engineering, where the flow of water has to get under control. Water can sometimes gain so much speed that makes itself unstable, and that causes the flow of water to get out of control. That can happen in many cases where open channel systems transport water to other places and cities. Velocity can be a factor that eases the transportation, but a variety of systems are built at the end of the open channels to convert the kinetic energy coming from velocity to an excess energy of heat. This is when hydraulic jumps take place in open channel systems to stable the flow of water.